Stick with me, I'll make you famous. I will take you places to see different faces. This is Matthew Msingati, the designer and developer. Welcome to my YouTube channel, Coded Design, where I teach coding and user interface design. In this video, I'm going to draw a picture of a beautiful lady. And in the process, I'm going to teach you advanced architectural software principle and design. The reason why I'm doing this video is simply because in most coding channel, this is a topic that is not talked about. I don't know for what reason. So I've decided if I'm going to talk about design pattern and also solid principle and also architectural tools and technique, I must make it interesting, and also I must make sure that you understand it by taking something that you know, which is art and drawing, and translate it into software development. Without wasting time, let's just jump straight into it. So I don't know other artists how they do things, but with me, what I do before I draw anything, I first work on the proportion. So to make sure that I keep things proportional, what I do, I always draw a Cartesian plane. So what is a Cartesian plane? In simple terms, it's just a cross. So let's quickly do that. But in doing so, we just need to make sure that the angle of our cross is 90 degrees. How are we going to make sure that we do that? Okay, this is how we can do that. We take this paper and we take our ruler. We are sure that this ruler is 100% straight. So instead of drawing a line that might be like this or a line that might be like this, we can draw a line that is 100% straight by doing what? By aligning the edge of the ruler to the edge of the paper. Just like this. You see? Let's just draw this line. Okay? The other thing that we can do, let's just continue with this line to the other side of the paper. So this is my own way of explaining things that are a bit difficult to be explained, things like software architecture and also design pattern. So in using this technique, it's going to be easier for me, first of all, to explain to you how this thing works, and also how studying software architecture can help you to write a better code. And the best way to do that is to do it through drawing. Okay, that is it, guys. This is our Cartesian plane. Well, designers might know this as a grid, because in graphic design software and design program, or also graphic design industry, this comes as a grid. There are more lines going this way, and also there are more lines going this way, and it becomes a grid, but it's the same thing. Now the only thing that we want to do here, we want to draw the lines. So let's just put our ruler here and just mark our lines, our numbers. Let's say from here, 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 and here, 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 here. That's it. Nothing much, nothing complicated. And then we are going to do this also, and then we will be done. And then after this, we are going to jump straight into software development architecture. Okay, 7, 8, 9, 10, 11. Guys, that is it. Now we have completed the first part of our task, which is to draw a Cartesian plane. Now let's jump straight into software development. How does this relate to software development? Okay, let's just take a new piece of paper. Okay, now I'm going to talk about the design pattern, but not all of them. I'm just going to talk about 2 design patterns and show you how do they relate into the drawing that we have done. Excuse my writing. Okay, the first design pattern that we are going to talk about it's a single point. It's either point of access, it's a single point of access, or it's a single entrance point. Okay, whatever the term is, but the single point of access or the single entrance point states that in your web application or in your application there must be a single point of entrance. What is a single point of entrance? Just like in any house, that there is no, you never heard that there's a guy who entered the house through the window, or maybe by the whatever, by a certain hole at the back, but you always come through the door. This acts as a single point of entrance, so that there could no person who can just jump into the house or get into the house through the window. So what does that mean? Let's just take this to web application. In web application, you must have an index file, index.php. This is a file that will always be an open door for HTML, JavaScript, and CSS, but particularly let's say JavaScript, because it's JavaScript that is going to make an AJAX call to this script. Okay, so let's just write here JS. So whenever somebody press a button and request something, sorry about that disturbance, whenever somebody makes a request on the UI, and then this JavaScript must always come to knock at this door. This is the single point of entrance, meaning that we are avoiding the situation whereby we've got all these JavaScripts, they are looking for different files from different angles. How will that make our life complicated? This means that if we want to make sure that these JavaScript requests, they conform to certain rules, for instance, let's say they must all be strings. Let's say we want to validate that all the JavaScript requests that are coming here, they must all be strings, let's say. That will be a validation. It will mean that if we've got these files requesting or pulling PHP files from all over the place, it will mean we have to write this validation here, we have to write this validation here, we have to write this validation here. And you know, in coding there is a principle called the try principle. Do not repeat yourself. As soon as you write one thing more than 3 times, then we've got a problem. That means you are violating the try principle. So it means that if we stick to the single point of entrance or the single entrance point, it will mean that we will only write the validation here. JavaScript will knock at our door. We will say, hi, JavaScript, come inside. When JavaScript come inside, we will tell them that this is the rule. As a rule in this house, we always take off our shoes. That means we validate. So all the JavaScript, they must point to this one script. Do you understand that? Yes. Let's just end here for now. Let's just take only this design pattern. I will talk about the other one as we continue. So in this Cartesian plane in drawing acts as a design pattern. Obviously in the final drawing, because I'm going to erase this, you're not going to see it, but it serves as a basis or as a foundation. Maybe the reason why most coding or most YouTube coders, they miss this part of coding, it's because you cannot really tell, or you cannot really see. But if you have used one of the most famous social media application, let's say Twitter, you will see that these applications are consistent. They are very exact, they are functional, they are accurate, and they don't break. They've got minimal errors, very minimal errors. The reason is the software design patterns and architecture, not coding. So obviously when you are new into coding, get into YouTube and try to search some coding channel, you will always be taught about coding. We open Visual Studio Code, we type something, we type function, we type arrays and whatever. That's not wrong, but there is the next level. So now in our drawing, we have set up a foundation, and you will see how this foundation is going to help us in drawing a very at least decent drawing of this beautiful lady using only circles. Now let's just jump straight into it. So what I'm going to do here, I'm just going to mark 9 lines, and then somewhere in between, I think the half of 9, it's the half of 9, 4, 4, it's 8, and then 4.5, that will be the half of 9. Okay, so 4.5 will be in the middle, as you can see. So what we are trying to do here, we are going to quickly write 4 circles. It's not going to be complicated. I'm not going to use my artistic skills. This is not an art class. Okay, so this will be my first line, as you can see, and then also this is going to be 4.5, and then this is going to be my other line. 9 ends here. Okay, as you can see, sorry, I don't see my other line. Okay, here is it. So what we are going to do, we are just going to quickly write a circle, draw a circle. Okay, let's just quickly do that. You don't need to have some artistic skills here because this is not an art class. But I just want to show you the importance of this Cartesian plane on keeping the proportion of this drawing. And in the final drawing, you are not going to see it because it's going to be deleted. But it has played an important role in keeping the diagram proportional. Very big and important role. As you can see, this is our first circle. Does this look like a beautiful lady? No. Of course, I hope this is clear. Yes, I hope you can see. Okay? Now that we have done that, 4.5 and 4.5. So now that we have done that, what we are going to do, we are going to draw the next circle. Okay? So what I'm going to do, I'm just going to draw all these 4 circles without explaining too much, and then we will take it from there. So this is going to be the first circle, this is the second circle. Let's just this is the first circle. Okay, and then let's just write the third circle here. Okay, this is going to be the first circle, second circle, and the third circle. Okay, make sure, note this. Okay, just a moment, I'm a bit lost somewhere here in my own techniques. Okay, this is the first circle and the second circle. Okay, this is the first circle and the second circle. Okay, same thing here. This is the first circle, second circle, first circle, second circle. Okay, now I'm just going to draw the first circle, sorry, the second circle, second circle. Here is our second circle, second circle. So this Cartesian plane is very important on making sure that it keeps the proportion of our drawing. That's what the design patterns are doing in your application. They make sure that they keep the proportion so that the application can be easy to maintain, and also it can be easier to scale. The reason why we failed as coders on coming up with applications that are scalable, application that can be converted to product, it's simply because our application, they are just lines of code, meaning that they are functional. Yes, of course, many coders, they can write functional applications or functional code, but now ask him to change something and then he will tell you that I need 2 months to change whatever that I want to change. I hope this is clear to you. As you can see that if you hear some noise, this is just my dog next to me. Okay, as you can see that this is just 1, 2, 3. Now we only need the last line. However, don't mind, what we are going to do, we are going to put the last line together. What I'm going to do now, I'm just going to pause the video. I'm just going to make sure that I write these lines clearly as they are without making them perfect. I don't want to waste your time. Okay, I'm back again. What I've decided to do, number one, I have removed our Cartesian plane, our cross, and the second thing, I've just decided to draw the fourth line. As you can see, what we have here is just 4 lines. 1, 2, 3, 4, and that's it. At this stage, can you tell what this is? Or is this close to a diagram or a drawing of a beautiful lady? Far from it. That's the problem that we have in the programming, coding, or even software development industry in general, because these techniques and design pattern and principle, they don't appeal to functionality. When you are starting planning your code, you are trying to adapt to good programming practices and software architecture, things like MVC pattern. When you are trying to understand those things, they are too far from code. So if you can find a channel, instead of teaching you arrays, function, variables, and CSS, it talks to you about MVC, it talks to you about design pattern, it talks to you about solid principle, and it talks to you about dry principle. What are you going to do? You always move away from that channel to another channel because it doesn't really show interesting things. That's the problem. Everything that will matter in life doesn't seem interesting, but it's very important. As you can see in this drawing, those lines, you cannot really see the impact of them. And also when you look at this drawing, you cannot tell what it is. That's the importance of design patterns. So now let's jump straight to another part of the design pattern. We will come back to the drawing, and now when we come back, we will draw something that is realistic, or whatever that we're going to add. You will start to see now the picture of the beautiful lady will start to show there. Let's come back to the design patterns. Okay, in software development, more especially object-oriented programming, when you start working on your application, you start to instantiate object. When you are creating a new object, let's say I'm saying new item in object-oriented programming, this part is called instantiation. So you will realize that when you are creating an instance of an object, you are creating a new class, let's say, you will find out that the class that you are creating, the class item, requires some dependencies, or there are some things that it depends on. In order for it to work, it depends on something. Let's just make a practical example. Whenever you create an item of invoice, this is an item of invoice, and you are saying new invoice, and then this is new invoice. Okay, let me just make this bracket very big because I'm going to fit a lot of things here. When you are creating an invoice, the actual invoice needs to have a tax. So meaning that, are you going to calculate a tax in this class of invoice, or you are going to have another class which is called tax that you can always put in here, or you will always inject? And remember, dependency injection is another design principle. So if we are injecting things here, that means we are sticking to the design principle. So what we are going to do, we are going to inject a text object here. It will calculate the text for us. Why must not we take this text object and put it inside this class, in the scope of this class? Number one, we won't be sticking to the solid principle. It will mean that we are having a class invoice that also calculates text. That means it's creating some sort of a functionality that really doesn't relate directly to it. What if the text changes? Do you see that we are going to come to a class invoice and modify it, only modifying it for something that it cares less about, which is text? So to become smarter, we are going to inject this text class, because text and invoice are two different things. I think the difference is in the word. It's invoice, it's text. So these are two different things. So we are going to inject text so that this class invoice can use a text. Then you will find out that then again, this invoice, it needs a certain class that creates a PDF, because once this class is done, it must render a PDF. So we can't just, in this thousand lines of a invoice class, we add another thousand lines of a module that creates a PDF. That means we are not sticking to the solid principle, single responsibility. So we need to inject, let's say, the PDF generator. So then in object-oriented programming, as you get into creating an application, or when you try to create an application, as Uncle Bob once said, that you will kind of see that this whole application thing now it's starting to become dependency management. Meaning that this class, before you instantiate it, it will need some dependencies. These are dependencies. These are things that it depends on, but it is not the things. Meaning that an invoice is an invoice. It uses a text class, it uses a PDF class, but it is not a text, it is not a PDF. It can function without these things. Meaning that even if you can substitute another text class, as long as it remains a text class, is going to use it. Even if you substitute another PDF creator, maybe now you've decided to change your PDF creator to a different one, as long as it's a PDF creator, it will use it. And then you will find out that now you've got a lot of dependencies that you need to manage. Let me just draw a map of what I'm saying. Now you need to know that before you create an invoice class, it will need a text class, it will need a PDF class, let's say it will need, let's say, a document class, or let's say itself it inherits from a document class, because it is a document, it is a business document, just like an invoice and just like a quotation, because those are business documents. So you will find out that you've got all these dependencies that you have to deal with. So if you are not using object-oriented programming good practices and pattern, you will get lost in this dependency management thing, because this is how you will normally do it, and it's going to stress you and it's going to be difficult to maintain. You are going to say new item because you are not aware of the dependency injection principle. You are going to say new item, and then in this text you are going to say new text, and you realize that when you are newing up, when you're instantiating text need another dependency, then because it needs another thing to work on. Let's say rates, there is a class called rates that this class text uses. And then when you come to the PDF generator and then you say comma, you are also passing a new PDF, and find out the PDF maybe works with a certain writing engine. Then we're going to say new writing engine, and then this writing engine, obviously it will need a certain stream or whatever technology that it will need. Let's say it's a document generator, and then you say new DG. Just by creating one invoice, now you are starting to write a very long line of code where you are newing up an invoice, and then that invoice takes a dependency which is a text. That text takes another new, and that PDF takes another new, and find that out you are writing this line of code. Now let us use a design pattern called the factory. And what the factory does, it solves this problem. What you are going to do, you are going to create a class which you are going to call it a factory. In my case, I always call it dependency injection container. That's what I call it. I don't usually call it a factory, but the factory pattern works the same. It doesn't tell you how you must write your classes, but as long as it's going to be a factory. So for now, let's call it a factory. This is a factory. What happens in a factory? A factory receives raw materials and it manufactures products on those raw materials. The same thing is done by this class factory. What it will do, it will have a method called getInvoice. It's going to be a static method, getInvoice. Then when you are running this method, you will find out that this method, what it will do, it will return invoice. Okay, this method will return invoice. However, before you create an invoice, this invoice thing will need a text class being created. So what will happen is inside the get text invoice, we will create a new invoice which will need a text. So instead of this invoice newing up the text, it will just receive it as a parameter, or it will just get text. Get text is a function that is inside the factory that is responsible for generating a text. So let's say we've got get text here that will only return a text, and then from then going forward, this invoice also uses get PDF. I think my space is small here, but please stick to what I'm saying. So this invoice, now instead of saying new, it will just ask for get PDF, and then inside this class factory there is a function called get PDF that is responsible for creating a PDF and returning it. So let me just try to write things clearer without making things a little bit unclear. So in the factory, we are going to have an invoice, which is it's a get invoice method. This get invoice will return the invoice in the end. It will return invoice, but before it returns invoice, it needs a text. It is not going to say new text, it's not going to instantiate a text, but it's just going to call a method called get text. That method will provide a text for it, a text class for it. Then it will just use, let me just cheat, it will use get text, it will use get PDF. And then in the same class, there will be a method called getPDF that is responsible for creating a new PDF. If this new getText needs a rate class, then we will have another method called getRate where it will create a new rate. I hope now you get how things are being done in the factory. However, when we talk of the client code, which is where we are going to use this factory, it knows nothing about this complicated mess of production happening in the factory. But the only thing that you are going to do in your client code, you will just always call or always use this factory. For instance, let me just write a simple code that is not accurate, but it will communicate the idea. Now let's say where we were creating a new invoice. Let's say now we want to create a new invoice. Before we do that, we are going to say in PHP a variable called factory is equal to new factory. So inside this variable factory, we've got this whole factory now. We've just taken the whole factory and we have put it inside this variable factory. So when we are saying new invoice, now we are creating a new, okay, now instead of instantiating, remember the reason why we've got a factory, we are avoiding into the client code newing things. So it will mean that if I've got invoice here, variable invoice inv, what I'm going to do, I'm just going to say it is equal to factory, which is factory, and I will call for that static method, which is get invoice, because the factory can manufacture the invoice for me. Do you see how simple this thing is as compared to what we did before? New invoice, and then in bracket new text, and then the text need another dependency which is new rate, and then when we are done that, we say new PDF generator, and the PDF generator needs a new thing. So now we just say invoice is equal to, and then we just say get invoice from the factory. The factory will do all the complicated stuff, and then when it's done with all that, it will just return the invoice class ready to be used. This is design pattern. This is more of the architectural side of things. This principle will make your life easier. So imagine if you were writing an application for a client and you were doing it, let's say, the wrong way or the difficult way, where you've got new. Meaning that when another designer come in to check your code, it's going to be very complicated. But if you use design pattern, remember, design pattern are more like universal standard. A guy from South Africa and a guy from Baghdad or the guy from Ghana, they know the same thing. If you know, you know. So it will mean that you will understand that, oh, this is a factory because I can see that this class, even if the name is not the factory, as I've told you that in my coding, I call these dependency injection containers. That's what I call it. So this means it's a container. It contains all the dependency injection. So whatever you call it, but the other person can also know. Most coding channel, they just get into coding and typing function without talking about this. Now, do you see how this factory has made our life easier? Now, allow me to go back to the drawing. Back to the art. This is what that Cartesian plane was doing for us. It was setting the rules for what we are going to do. Now let's just finish and perfect the picture of our beautiful lady. How are we going to do that? Let's continue. Now what we want to do, I'm going to draw a shape here that I think it will make this picture very clear, and I'm going to draw it here. Okay, let me draw it here. Okay, it's not that proper, but it will solve the problem. Now I think now at least you are supposed to have a clue as to where is the nose and where is the mouth and where is the other thing. But let me just continue. I'm hoping that now you are starting to get the idea. Let me just continue. In case you didn't get it, now I'm hoping you will get it. I'm hoping now it's going to be clear. The picture of our beautiful lady, it's going to be clear. Now you can tell where is the long beautiful hair and the beautiful face and the beautiful nose. You want to tell me even now you don't have a clue, but don't mind, I do understand where you're coming from. Let me add another clue. And remember, the clues that we are adding them on top of a very solid structure. So we are not just adding randomly the clues, we are adding the clues on the very solid structure. And also important to note the distance between the circles. Remember we said the Cartesian plane, which was the cross, it's the design patterns. Excuse my bad writing. The distance between the cross, the one that maintains the proportion, let's say the proportion of the design, it's being maintained by solid principle. In this video, I'm not going to discuss in details about the solid principle. I'm just going to name them for you, and that will be it. So let's just continue and finish the drawing to get things going. Okay, now I'm going to draw my last object that is going to tell you how does my beautiful lady looks, or exactly what's going on. This is the last thing that I'm hoping it's supposed to complete the picture of the beautiful lady that I have promised to draw for you. Okay, let me just draw another organ. Maybe these are her ears, and this is the mouth. This is the mouth. Okay, let me make it clear so that you can see. Do you get it? If you still don't get it, let me just draw one small thing. Maybe it might or it might not give you an idea. Still not clear. As you can see, this is a can in a top view. So that's what I was drawing here. This is a can in a top view. Let me just quickly make this part black so that you can have an idea. So this is a top view of a can. Okay, this is a top view of a can. So usually this hole, when the can is empty, even if it has got something, let's assume that it has got a Coke. There is a Coke inside. I hope now you get the idea. So what has helped us in terms of the structure, it's the design pattern. And the distance between these circle, it's the solid principle. What are solid principle? Solid principle is an acronym that stands for single responsibility, which is the S, and the O stands for open close principle, and the L stands for Liskov substitution, and the I stands for interface segregation, and the D stands for dependency inversion. So interface segregation and dependency inversion, I can explain those in detail in the next video. Now let's finalize things and show you how does coding feature in this whole puzzle. Now let's start to code. Remember, we've started with the design pattern, and I've told you what design pattern do, and these are the solid principle. I will tell you what solid principles do. They are responsible for the distance between these lines, maintaining the proportion. Now let's start to code. Coding is shading. So when you are doing your own shading, you are just bringing life into your drawing. Obviously, my shading is not going to be that perfect because this is a video tutorial and this is not an art class. I want you to get an idea of what's going on here. Okay. First of all, this might have been a mistake. This double line was not supposed to be here. It was supposed to be here. Let's just quickly do a rough sketch to fix that one. It's my mistake. Maybe I was in a hurry, but I hope you got the idea of what was going on in this diagram. As you can see that even if we have made the mistake, but that doesn't take much away from our drawing. That doesn't take much from our drawing. It takes, but it didn't take much. Okay, so meaning that this one is supposed to be a single line. Let's see if I can erase. Okay, it's going to take some time. Now let's just go to the shading, which is this is the coding. Okay, now what we are going to do, we are just going to draw lines here, something like this. We are just going to draw lines here, and we are hoping that these lines will create a perspective, meaning that the perspective is they must make that part of a can that looks like it's slanting like this. It's not a flat surface. This creates an illusion that this surface or this area, it's slanting like this instead of being straight. So that's the illusion that we are creating. That's why we are creating these lines in a more at an angle than just creating them straight. As you can see now, I'm hoping that you are starting to see that this is the picture of a can. This part now in our drawing, it's coding. Do you see where coding lies? Obviously, by the looks of things, it's the coding that gives this whole drawing or structure a shape or a look and feel. It's coding. I don't also dispute that, because without coding we cannot really have the actual functioning application. But as YouTube coders and developers and whatever we call ourselves, we need to also know that there are some things or higher level tools that can help us in order to bring our code into meaningful and usable products. I hope you see what this illusion thing is doing. So as you can see now, this is starting to be more like a realistic. Now let's add one layer of code and we are done. Then you've got the complete picture. Now we are doing also the shading. So this is the body of the can. So what we can do, we can just apply some small shading. Obviously it's not 100%, it's not perfect, but this is what coding does. This is what coding does to your own application. So when the application is being built, all the things, all the structure, all the frame and the engineering or whatever, or the architecture is being done by other guys. They are responsible for making decision as to how these class are going to interact and work with one another. That is done by other people. And then us as coders, we are called later in the, I'm not sure, in the development phase to say that do it, not necessarily do it this way, but build it from this concept, and this is how it's supposed to function. And then we come and then we code, and then you'll find out that when we are kicked out of those coding job, we can't come up with our own product. The reason is we were occupying a very small piece of the puzzle, even though us, we thought that we were the main guys, but we were not the guys who were. So as you can see now, our diagram is starting to take form. Now lastly, let me just add some sort of a perspective of the sun. Obviously this one is not going to be that 100% perfect, but after I'm done with this, you will have an illusion of the sun was on the left or the sun was on the right or something like that. I'm just going to draw random shadows, but they will give you an idea of where the sun is coming from. Okay, so what I'm going to do, I'm going to make this part a little bit darker. This part, which is the left part, this side is going to be a bit dark. So I'm just going to draw some dark shadows. And remember, this is not some sort of a well thought of thing, but I'm just throwing random shades. That's what I do. That's what I'm doing. The people who know how to draw them, maybe they might say that no, these shadows are wrong. Maybe they were supposed to be more on the left, because when the sun comes on the right, the shadows can be only. I do understand that, but in my case, I'm not an expert in drawing, but I'm just drawing to communicate a message or to help other people to understand programming, and also in an interesting way. So as you can see that this part is a bit darker. This is coding. Remember, we are not drawing here. In fact, we are coding, but we are coding artistically. Interesting. Artistic coding. Okay, this is my first dark shade, and then I'm going to do my other dark shade here in this part. And then from then we are going to look at this diagram and see what difference does these dark shading, that the shades make. Are they going to give us the illusion that maybe there is too much light on a certain area or less light in a certain area, or it's not going to? Let's see. Okay, here it must be a little bit strong, and then it needs to be lighter as time goes by. As I move away, it needs to be lighter, but it must be there. But it must be lighter. Okay. Okay, can you start to see if now the diagram is starting to get life, and it's looking different? So guys, I'm Matthew Msingati, the designer and developer. If you feel like this video has added value into your overall understanding of design, pattern, and programming, and software architecture and engineering things, please do me a favor. Please do me a favor and hit that subscribe button. So now what I'm going to do, I'm just going to finish my shading a little bit. And for me, guys, that is this. Remember, this is art. This is freehand drawing, so it doesn't have to look in a certain way. So guys, this is coding. Now we are busy with coding here. As you can see, that coding gives it that final look, finishing touch. Stick with me, I will make you famous. I will take you places to see different faces. Otherwise, for me, Hlazom Singati, the designer and developer, that's all I wanted to communicate to you. Please do me a favor and hit that subscribe button so that I can be closer to reaching my goal, which is 1,000 subscribers. Thank you so much for watching. See you on the next one.